All right, folks. So in the previous video, we talked about lamps for the atomic absorption spectrometer. And these lamps are very important because the lamps are really how the machine works. And if you don't have the proper lamp, you're not going to be able to run or analyze anything at all. So just a couple of recaps about the lamp itself. Number one is you have to choose the proper wavelength. So up here at the very top, you're going to see this magical word of primary, secondary, and tertiary. Now, what does primary, secondary, tertiary mean? Well, we're not going to talk about that yet. That is to come. But I have to make sure that I pick the proper wavelength to run the sample at. And the reason we're going to hold off on this is because it's directly related to concentration work and calibration curve work. And that's when we'll talk about it. So, primary, secondary, tertiary, you do not know now. You don't understand the difference of it. That's okay. I don't want you to know the differences of them, but you've got to choose the proper wavelength overall. Second, we talked about choosing the proper slit width that the lamp has to look through as far as the keyhole width goes. We've also talked about alignment of the lamp. So you have to make sure that the vertical position is aligned the proper way and that the horizontal position is aligned the proper way. You also have to double check the lamp's voltage. So you've got to look on the label to figure out what the ideal voltage is concerning the lamp. And you have to make sure the machine understands that. And then we've also talked now the lamps are universal. So no matter where you order the lamps from, they typically will fit any type of atomic absorption spectrometer. Okay, so that's an overall recap of the light bulb and the lamp as we've discussed in the previous videos. Okay, all right, so now we need to talk about the flame. And the flame of the AA instrument is probably almost important as the light bulb. And there's probably a couple of other settings that you're going to have to make in the burner head itself to double check to make sure that that whole area of the machine is working the proper way. Now, I told you the AA is very high maintenance, correct? So with that means that you're going to kind of look at this instrument and say it takes longer to set up the instrument than it does to run samples. And, quite honestly, this is the common thing for an AA instrument. People understand that it takes longer to start the machine up every day than it does to run samples because each sample will only take a couple of seconds and it's done. Your job is finished for the day. But to set the instrument up the proper way, sometimes that can take hours. So that's always the struggle with the AA field. All right, now let's kind of talk about this issue of the burner head. So the first thing that you have to understand is that the burner head is really only equipped to take liquid samples. That's typically what we're analyzing on an atomic absorption spectrometer. This is not like an infrared that can take a solid liquid or gas. It's not like a UV that can take mainly liquids, but we could probably put gases in there as well. But the burner head is strictly really meant for liquid samples. Now, what that means is that it has to be in a liquid form when it gets presented to the machine. Now, what about before it gets presented to the machine? Well, it can be a solid. So, for instance, I can take a nail, and I know that nail is made up of metals, so that's why I'm using it. And I can take that solid object and I can dissolve that nail, probably in nitric acid. And this will give me a liquid solution that I can then run on the AA instrument. But I can't just put a nail in the burner head of the machine. Now, you probably snicker when I say that, but these are some of the things that I have to say because, my opinion, they might be common sense. But they're things that I cannot take for granted. Okay? So you cannot put solid objects in the AA instrument. You have to be able to suck up liquid samples into the machine and allow them to work that way. Okay? So they can be solids in the beginning, but they're going to have to be dissolved down and they're going to have to be converted over to a liquid in order for the machine to analyze them. One of the very first settings on the burner head is basically how fast is it sucking. Yeah, that's supposed to be sucking, that word there. I know it's a scribble, but that's what that's supposed to be. So there is a ideal rate of which this burner head should suck up sample, and that ideal rate is 10 milliliters per minute. So before I do anything at all to the machine's burner head, I just want to make sure that that burner head is sucking up my sample at the proper rate. So what I typically do is that I would go and I would get a graduated cylinder, and then I would fill it full of water. That's as simple as it can be. Doesn't matter even if it's distilled or deionized water. It can be tap water for all I care. You're just measuring the rate. That's it. How fast is it sucking up? So you're going to get a graduated cylinder. You're going to fill it full of water. Okay? And you're going to bring this graduated cylinder over to the burner head, and you're going to stick a piece of the plastic tubing inside of the graduated cylinder while the machine is on. So the flame has to be on, the burner head has to be activated, and the machine, of course, has to be on. So then, number two, you're going to time it. Get you a stopwatch. And you want to go for 1 minute. 60 seconds, people. And you just allow that burner head to suck up that DI water out of the graduated cylinder for a minute. And then what happens is that you will look at this graduated cylinder and you know where it started and you know where it's going to end up. And of course, you take the difference. And when you take the difference between those two levels, you will get how many milliliters it sucked up for every minute. And you only recorded it for 1 minute. This should be close to 10. If it is not close to 10 milliliters, then you either need to speed the suction up or slow the suction down. You also want to make sure that this tube is not clogged, because chances are it could get a very small particle on the inside that can clog the suction up, and this is what's changing your rate, or your flow rate is what we would call this. There is a cleaning wire that you can use, and that cleaning wire is a very thin piece of metal that fits perfectly down into the nebulizer tube. And that's what we call the piece of plastic. It's called the nebulizer tube. What is the nebulizer? We'll find out in just a second. Okay, so I would stick this cleaning wire down into the nebulizer tube, make sure that it's not clogged up. I would try maybe the 10 milliliters again, and if it's still not 10 milliliters, then there is a knob typically on the front of the machine. So I'm going to try to attempt to draw this. Let's say that this is my burner head, and this is where the flame is coming up from the burner head. All right, well, down here below the burner head, there's typically going to be a knob. And my plastic tubing will come into this area really close to it. So just track the plastic tubing, the nebulizer tube, up, and then you'll see a round knob that sits there below the burner head. That round knob can be adjusted. And you would turn it up or turn it down until you can get 10 milliliters a minute. This knob has a proper name for it, and the knob is called the impact bead. So this is something that you have to check to make sure that it's operating the proper way before you begin to analyze samples. If the impact bead is not adjusted the proper way, it's not going to suck up the proper amount of sample that needs to go into the flame. And if the proper amount of sample doesn't go into the flame, then a proper signal on the machine is not going to be recorded. So that's an issue that we always have to deal with. We really have to double check the flow rate on this nebulizer tube before we run samples at all. All right, so we're not even talking about the burner head yet. This is kind of a piece that's attached to the burner head. And this is one of the first things that I want to double check when I run samples for the day or when a shift change happens and I come in and start taking control over the machine from someone else. I want to double check the flow rate before I start analyzing samples and wasting my time. Okay, so the impact bead has to be adjusted. You want 10 mils a minute of sample getting sucked through the machine. And then when that impact bead is adjusted the proper way, then you can go on about your business and maybe start looking closer at the burner head. And that's what we'll talk about in the next video. We'll turn over to the burner head, show you a couple of different variations and some of the settings that have to be made on the burner head itself.